Everything we see, the stars, the planets, the sprawling galaxies, and even us, makes up just a sliver of reality. Less than 5% of the universe is stuff we can touch or see. The rest, it's a cosmic mystery, cloaked in darkness, defying our best attempts to understand it. But now the James Webb Space Telescope is peering deeper into the abyss than ever before. And what it's finding isn't just breathtaking, it's unsettling. These aren't mere images of distant stars or colorful nebulae. They're glimpses of something that might force us to rewrite the rules of existence itself. From the strange behavior of galaxies to hints of structures that shouldn't be possible, the universe is whispering that we've been looking at it all wrong. One scientist put it starkly, "The cosmos isn't just teaching us new lessons, it's hinting we've been reading the wrong book entirely." So in this video, we're going to dive into the heart of these discoveries, step by step, unraveling what the telescope is showing us and what it means for everything we thought we knew. Trust me, the deeper we go, the more reality starts to feel like science fiction. But before we plunge into the cosmic deep end, let's start with something fundamental. The universe is expanding. This isn't news. Since the 1920s, we've known that galaxies are racing away from each other, like dots on an inflating balloon. The farther a galaxy is, the faster it's receding. This expansion is the heartbeat of cosmology, measured by a number called the Hubble constant. It tells us how fast the universe is stretching, and for decades, we thought we had it figured out. But then, the telescope turned its golden mirror toward the ancient cosmos, and everything changed. The problem started with a discrepancy, a tension that's been nagging at scientists for years. When we measure the Hubble constant using nearby stars and supernovae, we get one number, around 73 kilometers per second per megaparsec. But when we look at the cosmic microwave background, the faint glow left over from the Big Bang, we get a different number, closer to 67. For a while, scientists thought this mismatch, dubbed the Hubble tension, might be a measurement error. Maybe our telescopes weren't precise enough, or maybe we'd miscalculated the brightness of those pulsating stars. But the James Webb Space Telescope, with its unparalleled infrared vision, was supposed to settle the debate. It could peer farther and clearer than ever, calibrating distances to galaxies with exquisite precision. Instead of resolving the tension, it confirmed it. The universe is expanding at different rates, depending on where or when you look. This isn't a glitch. It's a crack in our understanding of reality. Let that sink in. The universe isn't behaving like it's supposed to. If the Hubble tension is real, it means something fundamental is missing from our cosmic model. Maybe it's dark energy, the mysterious force driving the universe's accelerating expansion. We've known about dark energy since the 1990s, when astronomers realized distant supernovae were farther away than expected. It's like an invisible hand pushing galaxies apart, and it makes up roughly 68% of the universe. But what if dark energy isn't constant, as we've assumed? What if it's changing over time, growing stronger or weaker? The telescope's data hints at this possibility, suggesting the universe's expansion isn't just speeding up, it might be doing so unevenly. This could mean dark energy isn't a single force, but something dynamic, something we've barely begun to grasp. And then there's dark matter, the invisible scaffolding that holds galaxies together. Without it, stars at the edges of galaxies would fly off into the void, like water flung from a spinning wheel. Dark matter's gravity keeps them in check, but we can't see it, touch it, or detect it directly. It's roughly 27% of the universe, yet it's a ghost. The telescope's images are now challenging even this cornerstone of cosmology. In some distant galaxies, observed just a few 100 million years after the Big Bang, the telescope is seeing structures that seem too massive, too well formed for dark matter to have sculpted so quickly. These galaxies, glowing like cosmic cities in the infant universe, shouldn't exist. They're too big, too mature, as if the universe skipped a step in its evolution. If dark matter isn't assembling galaxies as we thought, what is? This is where things get weirder. The telescope isn't just finding galaxies that defy our models. It's spotting anomalies that hint at something even more profound. In one survey, astronomers noticed a peculiar alignment in the rotation of galaxies. In a random universe, galaxies should spin in all directions like coins tossed in the air. But these galaxies, scattered across billions of light years, seem to prefer one direction. It's subtle, but it's there, growing stronger the farther back in time the telescope looks. This cosmic choreography isn't supposed to happen. It suggests the universe might have a kind of global spin, a built-in rotation we never accounted for. If true, this could mean our universe has a structure, a geometry we've never imagined. It's as if the cosmos itself is dancing to a rhythm we can't hear. Now let's push the boundaries even further. What if this alignment, this strange coherence, is a clue to something unimaginable? Some theorists are proposing a radical idea. Our universe might be inside another universe. It sounds like science fiction, but hear me out. The telescope's observations of early galaxies, those massive, impossibly mature structures, don't fit the timeline of the Big Bang. One hypothesis suggests these galaxies formed in a parent universe, a larger cosmos with different physical laws. When that universe underwent a catastrophic event, perhaps a collapse into a black hole, it birthed ours. The galaxies we see then could be relics, inherited from a reality beyond our own. This isn't just speculation, it's a theory grounded in the telescope's data, which shows structures too old, too complex for our universe's age. Imagine that for a moment. The universe we call home, with its 13.8 billion years of history, might be a bubble inside a vaster reality. The black hole that birthed us could still influence our cosmos, its event horizon sealing us off from the parent universe. This would explain the strange rotational alignment, as the spin of the parent black hole could imprint a preferred direction on our galaxies. It would also account for the Hubble tension, as the physics of the parent universe might bleed into ours, tweaking the expansion rate in ways we can't predict. The telescope's images are like postcards from this boundary, hinting at a reality where our universe is just one chapter in an infinite book. But there's another twist, one that challenges the very foundation of cosmology. The cosmic microwave background, that faint glow we've long seen as the Big Bang's afterglow, might not be what we thought. The telescope's deep field images show billions of early galaxies, their young, hot stars blazing with intense radiation. Over billions of years, this light could have redshifted, stretching into the microwave range we detect today. In other words, what we've called the echo of the Big Bang might be the combined glow of ancient galaxies, altered by cosmic expansion. If this is true, it's a seismic shift. The cosmic microwave background has been our strongest evidence for the Big Bang, a snapshot of the universe at 380,000 years old. If it's partly or entirely something else, we might need to rethink the universe's origin. This idea doesn't erase the Big Bang, but it complicates it. Maybe the universe didn't begin with a single explosion, but with a more gradual process, shaped by the light of countless galaxies. Or perhaps there was no beginning at all, just a transition from one state to another. A cosmic cycle we're only now glimpsing. The telescope's data suggests that early galaxies could contribute up to 2% of the cosmic microwave background's signal, a small but significant fraction. In precision cosmology, even a 2% discrepancy can unravel decades of assumptions. If this contribution grows as we study more galaxies, we might find that the universe's story is far stranger than a singular moment of creation. And then there's the question of what lies beyond. The telescope's infrared eyes have spotted objects so distant, so redshifted, they push the limits of our understanding. Some of these objects have redshift values exceeding 20, meaning they existed when the universe was just 200 million years old. These aren't just galaxies, they're beacons from a time when the cosmos was a cauldron of raw energy. Yet some appear structured with signs of older stars, as if they'd been evolving for far longer than the universe's age allows. One possibility is that these objects aren't in our universe at all. They could be glimpses of another cosmos, their light leaking through a cosmic boundary we can't yet define. This isn't fantasy. It's a hypothesis born from the telescope's relentless clarity. Let's pause and reflect on what this means. The universe we've studied for centuries, the one we've mapped with equations and telescopes, might be just a fragment of a larger reality. The Hubble tension, the strange galaxy alignments, the cosmic microwave background's ambiguity, all these are clues that our models are incomplete. The telescope is showing us that the cosmos isn't a neat, predictable system, but a labyrinth of mysteries. Dark matter, dark energy, even the Big Bang itself. These pillars of cosmology are wobbling, and in their place, new ideas are emerging. Universes within black holes, cyclic cosmologies, realities beyond our own. Each discovery is a step toward a truth we can't yet fully grasp. But here's the thing. This uncertainty isn't a failure. It's the pulse of science, the thrill of standing at the edge of the unknown. Every time the telescope captures a new image, it's like opening a door to a room we didn't know existed. The galaxies it reveals, the anomalies it uncovers, are the universe speaking to us, telling us to look closer, think deeper. Maybe we're inside a black hole. Maybe we're one universe among many. Or maybe the truth is something we haven't even dreamed of yet. What matters is that we're listening, and the telescope is our ear pressed against the cosmic wall. As we move forward, the telescope will keep pushing the boundaries, its mirror reflecting light from the dawn of time. Each new observation will bring us closer to understanding, or perhaps to even greater mysteries. The universe isn't just vast, it's alive with secrets, each one a challenge to our imagination. We're at the beginning of a new era, one where the cosmos is revealing itself in ways we never thought possible. And with every image, every spectrum, we're rewriting the story of existence itself. That's it for today's journey into the unknown. Thank you for coming along, and a special thanks to those who support this exploration of the cosmos. Until next time, keep looking up, stay curious, and we'll see you soon.